Yo, what's up, super peeps? We're going to keep going with kinetics. Actually, we're finishing up kinetics today. We're going to talk a little bit about reaction mechanisms and some elementary step stuff. And that really kind of finishes up our kinetics unit. So, let's get into it. Let's talk about reaction mechanisms. And we've talked a little bit about this before. All right, so our reaction mechanism is just a series of simple steps that lead from the initial reactants to the final products. So up until this point, we've really treated a chemical reaction as really just, it's one step, the reactions come together, they react, and they form products. And in a lot of cases, and I might even say most cases, that's actually not true. What happens is they go through multiple steps to get to the products. Right? So we often write chemical reactions as single steps, but most occur in a series of steps called elementary steps. Okay, so let's look at one. Here's an example. Ozone will decompose into diatomic oxygen using the following formula. O3 gas goes to 3O2 gas. So this looks like a single step, but in reality, it's not. Okay, so we've written this as a single step, but in reality, it's actually not. So the reaction mechanism for O3 to O2 is as follows. In reality, what happens when this occurs is O3 gas will go to O2 gas plus O gas. And then this O gas will react with another O3 gas, and it produces 2 O2 gas. So it's actually two steps. So this would be step one. This is the first thing that happens. And then this is step two. These would be the elementary steps. Sometimes they're called elementary reactions. Now, if you add up your elementary steps, it better equal the overall reaction. Right? So if we add these, let's use orange. If we add them, it better equal this guy up here. Right? So let's go ahead and add these. Well, what happens? These O's cancel. we have two O3s, gases, as reactants. Okay, so here are my arrows. Okay, so I have two O3s, and then on the product side of these, I have an O2 here, and I have two O2s over here, so this would be 3 O2 gas. Okay. And this matches my overall reaction. Come on, turn over. Now, the reaction mechanism of a reaction, it'll often change depending on temperature. Reaction mechanism will often change with, let's say this, changes in temperature or pressure. Okay, so the reaction mechanism can change depending on the conditions that we're in. And I want to give you an example. If we're at high temp, if we're at a high temperature, carbon monoxide gas will react with our nitrogen dioxide gas and become CO2 gas and nitrogen monoxide gas. At high temperatures, this is a single step. It's a one-step reaction. So at high temperatures, it is a one-step reaction. But at lower temperatures, this reaction changes. So at lower temperatures, it's actually a two-step mechanism. And the steps look like this. NO2 gas plus NO2 gas turns into NO3 gas and NO gas. And then my second step is CO gas plus NO3 gas goes to NO2 gas plus CO2 gas. Okay, so this would be step one, and this would be step two. The carbon monoxide doesn't even come into play until our second step at low temperatures. Now, these two steps better add up and be equal to what we had before. So let's go ahead and add them and make sure that they do. Right, so we can cancel some things out here. So we have an NO2 gas over here and an NO2 gas over here. So those are going to cancel. And I have an NO3 gas on this side and an NO3 gas on this side. So those are going to cancel. So now we can just go ahead and write our reactants and products. So in our reactants, we have NO2 gas, and then reactants down here, we have CO gas. So let's go CO gas plus NO2 gas. And that's going to, right, we got CO2 left and NO. And this matches our original. Okay. They match. Okay. So this would be what's called the overall reaction. So at high temperatures, it's just a single step. It does this thing. But at lower temperatures, we find that it goes through a two-step mechanism to get there. Right? It gets to the same place. It just gets there in different ways. Now, we have names for these elementary steps.